Assume that the paired data came from a population that is normally distributed. Use a 0.05 significance level and differences computed by x minus y, in other words, the list x minus the list y. Find the average difference, the standard deviation of the differences, the t-test statistic, and the critical values to test the claim that the population mean difference is 0. So we'll begin by opening the data in StatCrunch, and we will first find the differences between the paired x and y values. So we'll click Data, Compute Expression, and we will build the expression. We want to subtract the y column from the x column. So we'll click X, add column, minus y, add column, click OK. And then compute. Now this adds a column to the spreadsheet that has the differences in it, the differences between the paired values x and y. In the first entry, we have 6 minus 7, which gives us -1, and then 12 minus 13 gives us -1, and on down. In order to find the mean and standard deviation, we'll click Stat, Summary Stats, Columns, and use the x minus y column and click Compute. Now we have the mean, it's -1, and the standard deviation, 2.330 if we round to 3 decimal places as called for in the problem. Now we are to find the t-test statistic. So we'll open the data in StatCrunch again. This time we'll click Stat, T-stats, Paired. Make sure that the x column is sample 1 and the y column is sample 2, and then click Compute. Now we have a t-statistic of -1.214 if we round to 3 decimal places. Now we are to find the critical t-value. We have 1, 2, 3, 4, 5, 6, 7, 8 pairs of data. So that gives us 7 degrees of freedom, n minus 1, the number of pairs minus 1. So in order to find the critical t-value, we will use the calculator in StatCrunch for the t-distribution. So we'll open in StatCrunch again. We'll click Stat, Calculators, T, and then make sure that we specify 7 degrees of freedom. And since we have a 0.05 significance level given to us in the problem, and this is a two-tailed test, we'll type 0.025. Hit Compute, and this gives us a value of -2.365 if we round to 3 decimal places, and a t-value of -2.365 with 7 degrees of freedom would correspond to 0.025 of the distribution being in the tail. That also means that a positive 2.365 would give us 0.025 of the distribution in the upper tail. Our answer is to be in the form t equals plus or minus 2.365. We're given the plus or minus in the problem. We are to type in the critical t-value that corresponds to a significance level of 0.05 with 7 degrees of freedom.